Gravity is very special, and it's not just because it prevents you from flying. See, out of all the four forces in the universe, I think gravity is the one that has caused the most problems for physicists throughout the years. Just look at the history. Isaac Newton taught us all about the force gravity applies on us and the orbits that arise from it, but he didn't know what caused it. Then Albert Einstein came around and said gravity was this very geometric force caused by the warping of the four-dimensional space-time we live in. He said all objects with mass warp space-time, and the more mass the object has, the bigger the valley in space-time it creates. These valleys are what control gravity. But after Einstein's theory, which was called general relativity, by the way, it was a pretty big deal, these strong and weak nuclear forces were discovered, and quarks were discovered, and quantum physics was developed. As time went on, scientists had a deeper and deeper understanding of the universe, to the point that they finally tried to create a theory of everything, the Standard Model of particle physics. This model promised to be the theory that united all parts of physics, big and small, to explain the universe simply and elegantly. But unfortunately, it's missing one thing. You guessed it, gravity. And that is where we are today. Gravity still eludes us. We just cannot put it into the Standard Model without ruining all the nice mathematics, because by its geometric nature, gravity is fundamentally different from the electromagnetic and strong and weak forces. Gravity is meant to be the field on which all the other forces play, not some graviton particle. That is where string theory comes in. String theory is an alternate candidate for a theory of everything that defines particles as these incredibly tiny strings rather than points. These strings can vibrate at certain frequencies to create different particles. For example, a certain frequency on a string might create a photon, while a different one might create an electron. The promising thing about string theory is that it includes everything from the Standard Model plus gravity. Hey dude, it's physics, and I was just watching your video, and you said that string theory combines gravity and all the other forces into one theory. Isn't that the theory of everything already? Why are you even making this video?
See, there's a catch if you just let me finish.
See, the thing is, string theory tries to map out gravity as well as the other three forces onto the space-time continuum, which is a big problem because we only have 3 spatial dimensions and they all relate to gravity. So string theory awkwardly requires an additional 6 dimensions in order to fit all the other forces. Some physicists try to hide these 6 dimensions by saying they are too small or too big for us to even find. Other physicists are trying to elegantly use these extra spatial dimensions to explain other phenomena. Additionally, unlike the well-tested Standard Model, no predictions made by string theory have been empirically proven. The math it presents just works. But that has certainly not stopped scientists from trying to pursue a perfect model for string theory. With tools like the Large Hadron Collider, scientists are working to throw away or combine certain types of string theory to limit the number of possibilities. Because as of now, there are many different types of string theory that work under a wide variety of assumptions and produce a wide variety of conclusions. The late physicist Stephen Hawking said that one type of combined string theory, known as M-theory, has the best hopes for becoming the theory of everything. So maybe string theory is the answer. Or perhaps it is just another step in our journey to reconcile our understanding of gravity in the universe. Only time will tell. Thanks for watching.